welcome to this Unity tutorial on creating a 3D checkerboard by spawning the squares resized to the size of screen using orthographic camera. After that, you can add looping animations to square representatives and join several series by Craig S. Kaplan. Details will be in description. I suggest you check them out because it is really fun. For this project to work with no problems, there are some requirements regarding camera properties and some other things. The camera will be used to calculate the size of the checkerboard and the squares and will give us the position of the starting point. First, the camera should be orthographic because we will use transformation functions to determine the starting position. And I should share that it doesn't really look correct with a perspective camera, but if you're interested, let me know. Second, the camera should have no rotation. There will be no transformations to correct rotations and projections. One more thing, your screen should be square. This implementation targeted to be applied to square screens and dividing it to smaller squares. Lastly, if you want a seamless background, you should select solid color to be shown from clear flags and select background color for either white or black. Other than that, I suggest your light sources color to be pure white so that you get pure white from white squares. Here, Checkerboard Creator creates the checkerboard. It has two behaviors that we will interchange to do the spawning very slightly differently. CreateFullBoard creates the board with white and black squares. CreateBlackboard creates the board with only black squares. In orthographic projection, it feels like only black squares move, white ones stay still even though they don't exist. They both take row square count information, number of total squares in one row or column since our board is square. And CreateFullBoard takes reference to both black and white cubes to spawn them as a board squares, and CreateBlackboard only takes reference to the black cube. Let me give you a quick heads up on cube prefabs. CubeBody is the owner of the animations, and to preserve the scale when the cubes are scaled, it's placed into empty parent project, CubeBlack or CubeWhite. The only difference between them is the material of their child transform, CubeBody. I use direct game objects and not material color changing because even though the spawn count is low, I didn't want to go to get the render component of the child, set it as material to that. Doing this reduces material selection flexibility through code, but I can apply it from the editor. If this feels wrong to you, feel free to play around the logic. With that, I believe we are ready to have a code walkthrough, starting with CreateFullBoard Script. There are three components we take from the editor. Game objects, black cube and white cube, are for spawning when their order comes, and row square count for deciding how many squares in one row or column. Here we have a private variable called main camera to store the reference to main camera in the scene by setting its value to camera.main. With this, we are ready to call our board filling function, fill the board. First, we check if the camera is orthographic or not. If it is orthographic, we continue with our action, otherwise we send a warning to let the developer know they will not get a checkerboard, and to create one they should change the settings of the main camera. So we know the screen width or height from screen width and height in screen space, but we will be spawning our squares in world space. So we need to find the width or height in the world space. To do this, we store the word position of right up corner to max position vector and left down corner to min position vector. Right up corner corresponds to screen width and height, and left down corner is 0, 0. We get their world space positions by applying screen to world point camera transformation. After that, we calculate the size of each cube. Since we say the screen is a square, we can get x or y value of difference between the positions and divide it to row square count. Now we have all the information we need. Let's spawn the checkboard. We have I and j indexes for each looping for row square count, I for x, columns, and j for y, rows. In our loop body, we start by deciding which color of square board cube we will spawn. I have created a demo scene to show which indexes correspond to which board cubes. If we inspect indexing of the squares, we see that the sum of black ones is always even, and sum of white ones are always odd. With this information, if I plus j index sum is even, we instantiate black cube and set it as reference to board cube. Otherwise, we spawn white cube and put it as reference to the board cube. Only things left are scaling the square and put it to correct positioning on the reverse space. We set it as scale to square size for each axis and move it away from min position to times of its indexes plus half size for each axis. Here, the size is step size for movement. So for each step index, we move them that much. And half slice is so that there will be no overflow regarding center positioning of the object. For example, let's say we will span I equals 3 and j equals 2. We position the cube at the mean point, half right, half up. Now it is inside the board. Then 3 sizes right and 2 sizes up, we put it where it should be. And lastly, we want squares not to be clipped by the camera, so we give the positive z distance. Here it is 5. And the checkerboard is spanned. And if you want to span only one color, in this example black ones, the only difference between spanning the full board and the only one color is we won't span the non-target color and move the scaling and moving logic to brackets of target color. Then everything will be good to go. When you enter play mode, you will get your checkerboard. For the animation, whenever we create an animation for our core cube, cube body, and set it to default state in Animator by right-click on the animation, select Set as Layer Default State, and we done that. We are good to go. Testing out different animation loops are really fun, so you should do that. Lastly, you are free to change the count of cubes as we are spawning the checkerboard from code. You can go for 20 or 4, it will be up to you. Hoping you will enjoy creating new loops with this. With that, we are at the end of this tutorial. If there was a point not clear, please let me know in the comments down below. If you like this video, consider giving a like and subscribe for the future ones. Every week, I upload at least one new video on game dev, so you won't miss it. I hope to see you in the next explorations, and bye bye!